test coming up. Chapter 7. So it's page 594. And I mentioned last class that this test will have two parts to it. I'll give you part that must be completed by hand. And that means a few of you have graphing calculators. I will either loan you a different calculator or you need to come with a different calculator for the first part of that test. In the second part of that test, you may use your Chromebook for this matrix calculator, or you may use a graphing calculator for the second part of that test. So, let's see what we have.
It's like an average amount of points for the test.
Yeah, the test as a whole is still about the same size as a normal test. So it's just kind of like two one-page tests, making a two-page test what they normally are. Number 4, 594. Write the augmented matrix, the coefficient matrix, and the constant matrix. Part of what we learned in this chapter was vocabulary, maybe some new vocabulary from what we were used to before. So when they say augmented matrix, you need to remember that that is a matrix that involves all the coefficients and the answers in it. So if I look on number 4 in the first row, since there is nothing in the x spot, we know it will be a 0. Then what do we have? -4, 2, 5. So our augmented matrix, and you can start copying all those numbers, is simply all the coefficients. 3, 2, 0, 2. Including the answers. From 0, -7, -3. So this is called the augmented matrix. So just make sure you know what it means when they say augmented matrix. There's really no math. As long as you copy numbers, there's no math to do. Then they said, write the coefficient matrix, which is exactly what it means. The coefficients. So it's going to look exactly the same, except it will not have any of those answers. That is the coefficient matrix. And they want the constant matrix, which is just the what? Just the answers. That's it. So really, this is just all definition. You know what it means when we say augmented, coefficient, constant, that sort of stuff. 14, jumping way over there. Seems like we missed something important. Let's do 10. We need to know. Oh, no, that's okay. But let me talk about that whole section there. It says write the matrix in row echelon form. Who remembers what row echelon form was? The diagonal of 1s, 0s in the bottom left corner, and then all the other numbers. We're going to do this in a minute in order to solve some problems. So we've got other numbers over here. So if they ask you to write it in row echelon form, it means get it looking like this. We're going to use that process on number 14 to solve a system of equations using the Gaussian elimination method. So far, everything has been by hand. So I'll tell you when we get to a problem, but I'll let you just use a matrix calculator on that. So I first want to write the augmented matrix. So 3, 4, -9. And 2, 3, -7. And we want to get this into the row echelon form. So the first thing we want to do is make sure we have a 1 in this top left corner. So multiply 1/3 times row 1 should accomplish that for us. So I'm going to write my answer down here. So it will be 1, 4/3, -3. And the second row, nothing has happened. So one elementary row operation at a time. So once we make that top left a 1, then we go underneath it using that 1 to eliminate. So we know negative 2 times row 1 added to row 2 would cancel out that positive 2. So that will be the next elementary row operation. So the top row, 1 4/3 negative 3, I'm done with. Negative 2 plus 2, 0. Negative 8/3 plus 9/3 is 1/3. Double check my math. 6 minus 7, negative 1. I think I'm correct there. We'll soon find out. So I use that top left 1. Everything under it, even if it was bigger, I do the same thing. Everything under it I use to eliminate. Then I move over and I need to make this 1/3 a 1. So I can just multiply 3 times row 2 and it would make it a 1. Top row stays. Multiplying by 3, 0, 1, negative 3. Now that would be row echelon form, if they asked for that, which is the previous section. They just said, hey, get it in that point. But since we are solving, we now will turn this back into equations. The first two are the x and y values. So down here in my third row, I know that 1y equals negative 3. We know what y is. And then I can use the top row, 1x plus 4/3 times my y, which is a negative 3, must equal that negative 3. And we can solve for the x. So let's see, multiplying, that would be x minus 4 equals negative 3. Add my 4, x is 1. So if I did it right, 1 comma negative 3 is the solution of this one. 1 comma negative 3, good. 29. Same directions. This is just a 3 by 3 system, so a little bit bigger. So let's start making that augmented matrix. 1, 1, 2, negative 5. Here we'll be really careful, hopefully, and not make a little mistake. Same idea. I want the top left corner to be a 1, which it is. So I'm going to use that 1 and eliminate the numbers underneath it. So here on the second row, I'll go negative 2 times row 1 and add to row 2. And same thing for the third row. Negative 2 times row 1 and add to row 3. So when we are done doing those two things, we should have zeros underneath our first one. So the top row gets copied, nothing changes on it. We are done with it. We'll just copy it quite a few more times. And we will do our math. Negative 2 times row 1 added to row 2. So negative 2 plus 2, 0. Negative 2 and 3 make 1. Negative 4 and 5 make 1. 10 minus 13, negative 3. And as you're doing it, double check our answers together, make sure we agree. 0, negative 2, and 5 is 3, negative 4, and 7 is 3, 10. Are we still all on the same page? All right. So if I move over, well, this middle one is a 1, so I don't need to make it a 1. And remember, we make it a 1 by multiplying by fractions. That's always how we get 1s. So I can use that 1 underneath it to eliminate that 3. So negative 3 times row 2, add it to row 3. I just recopied my stuff that I'm copying always first to hopefully not make any mistakes. Those first two are actually all done now. All right. So 0 and 0 make 0. Negative 3 and 3 make 0. Negative 3 and 3 make 0. 9 minus 9 makes 0. So what does that mean? Does not mean no solution. It means infinitely many. Remember, right here is just like it's an equal sign. This is telling me 0 equals 0. That's true, but doesn't give us an answer. There are infinitely many solutions on this. A no solution one would be where this left side does not equal that last number. That would be a no solution. Like we had a 1 over here and then a 0 or something like that, where it's not true. So this is infinitely many. So how we will do that one, we'll make our z a constant. And we'll just say, okay, z is a constant. And then we'll come back to row 2, x, y, 1y, so I'll write y, plus 1z, so 1c, constant, equals negative 3. Using row 2, remember those first 3 columns are x, y, and z. That's what they stand for. So I have 1y and 1z, but we've called z a constant, equals negative 3, so I can solve for y. So just subtract that constant. I'm going to write it first. Negative c minus 3. There's our y value. Negative c minus 3. I now have my answer for the y. Yes?
So that 0 in front of the 1, you don't count that at all.
0 x's, so I don't need to write it, the x down. That's 0 x's. Okay? 1y, 1z equals negative 3 is what that row means. Now I'm coming to the top so I can get my x. This is 1x, x, plus 1y, so it's one of these things. Well, let me go ahead and say plus negative c minus 3. You could just write minus c minus 3. Plus 2 z's, 2 constants, because that's what z equals negative 5. So it's reinterpreting that row as an equation with x, y, and z. And we'll solve for x. So I'm going to put these like terms together. I have a negative c plus 2c, so that's plus c, minus 3 equals negative 5. And then rearranging it all, I'd have to subtract my c. I'd add 3, so it'd be a minus 2. So my x is a negative c minus 2. And there is our answer for infinitely many solutions. We could choose any constant for our z, and we could find the x and y that went with it. So we could generate an order triple. That would be one of the many, infinitely many solutions. What was that, 29? 40. So far, we're still all by hand in what we've done. Number 40, perform this indicated operation. So they have defined a bunch of matrices, A, B, C, and D. They've defined all these matrices, and they're saying on number 40, take 2 times A minus 3 times D. So we'll need to go 2 times matrix A, which I need to copy to negative 1, 3. Times matrix B. Just like distributing, so if I multiply everything by 2, 4, negative 2, 6, 6, 4, negative 2. Now what I am going to do is distribute the negative with that 3. So if I take the negative away, I'm going to be adding whatever answer I get. So I have a 9, negative 12, negative 6. negative 12, 6, negative 15. If you don't take the negative with it and only distribute the 3, then you would leave the minus there in the middle. Either way, you'll get the same answer. And now it's just a matter of adding all our corresponding elements. So let's see, 13, negative 14, 0, negative 6, 10, negative 17. Anybody else get that or not get that? Hopefully got it. All right, that was 40. 56. 56 is another definition. There's really no math to do. It just says, okay, write a system of equations from this matrix equation. So they have written it out as a matrix equation. They say to write it just as linear equations. So negative 1x or negative x plus 3y equals what does it equal? 5. All right. It's very easy to do. And what's the other one? 4x minus y equals 6. And according to the directions, that's all they wanted. Write a system of equations from the matrix equation. There it is. There's a system of equations. Test question. Maybe. Never know. 68. 68. Find the inverse, if it exists, of the given matrix. Let me do a different one. And then I'll talk about 68. Let's do 61. 61. Let's say it's the same directions. Find the inverse, it says. 2, negative 2, 3, negative 2. If you are given a 2 by 2 matrix and asked to find the inverse, I expect you to know how to do it by hand. So here's how we do it by hand. Finding the inverse of this matrix equals 1 divided by the determinant of this matrix. So we need to remember, how do we get the determinant of a 2 by 2 matrix? Multiply minus multiply. So we'll go 2 times negative 2, which is a negative 4, minus 3 times negative 2, which is a negative 6, and that all equals 2. 1 over 2. So to get an inverse, it's 1 divided by the determinant of the matrix times, then we need to rearrange this matrix. This diagonal changes places.
Wait, sorry, why'd you do 1 divided by 2? Our determinant is 2.
To find an inverse,
Inverse
of a matrix, you go 1 divided by the determinant of the matrix, multiplied by, and then we have to rearrange it. And rearranging it means we change the places of this diagonal. That becomes a negative 2, that becomes a positive 2. Now we've changed places. I know it looks like we just changed the signs, but we actually changed the positions of those numbers. And then on this diagonal, you do change the signs. So the 3 becomes a negative 3, and that negative 2 becomes a positive 2. So for this diagonal, you switch them. So there are some things to study and memorize. That diagonal, you switch them. This diagonal, you change the signs. And now we do our math, and that is the inverse. So I'm multiplying everything by 1/2. Please, whoever that is, turn it off. Was that mine?
Yeah, I think so. Mine. Those computer.
Okay, your computer? All right. Would you mind doing that? Thank you. I don't think I have anything that's beeping, especially since my sound is muted. All right. 1/2. Negative 1, 1, negative 3 over 2, 1. There is the answer. There is the inverse. If you are given a 2 by 2 and asked to do the inverse, I expect you to be able to do it by hand. Now, number 68 is a 3 by 3. I do not expect you to get a 3 by 3 inverse by hand because we didn't teach you how to do it. So, you can use the software. So I'll actually do the software just to remind you how to do the software. Let's see. I have to keep everything in my red box. Looks like everything is in my red box. So on number 68, 4, 9, negative 11, I should sit over here, I think. Then I'll have you help me. 4, 9, negative 11, what's the next row?
3, 7, negative 3.
Whoops, negative 8 you said, didn't you?
2, 6, negative 3.
Thank you. And then all you do is you find this little button that says, find the inverse. And you click that little button, and then you copy that answer onto the answer place on the test. Assuming that I give you one of those simple, easy ones like that. There's the answer to 68. There's the inverse. So we did not learn a by hand method of getting the inverse of a 3 by 3. I'll let you use technology to get the inverse of a 3 by 3 if you get one of those. Which will probably go on everybody's prayer list, right? What was that, 68? 76. All right. 76. This is a by hand knowledge question. So 76 says, solve the given system of equations for each set of constants. Use the inverse matrix method. So what they have done on 76 is they've given you different sets of answers. We'll just do one of them for our example, but that's what they mean for each set of constants. So let's see, 2x minus 5y equals, and for part A, what's b sub 1? Negative 3. 2x minus 7y. And b sub 2 is a 4. All right, so this will be the only one. This is part A of 76. Okay, inverse matrix method means I first write this as a matrix equation. So I write the coefficient matrix, 2, negative 5, 3, negative 7. Then we write the variable matrix, xy. And then we say it equals the constants, negative 3 and 4. A minute ago, they gave you one of these and said, write the system of equations. So here we're kind of do the reverse. They're giving us the system of equations, and we have to write the matrices. Now we're going to solve this. Inverse matrix method says this. If I have a matrix and I multiply it by its inverse, then it cancels it out, or it makes it 1, or it's called the identity. That matrix just has 1s on the diagonal, everything else 0. I have 1 xy. So on the left side, if I multiplied by the inverse of that matrix, it would just cancel it. I just have xy. And we know in algebra, whatever we do on the left side, we have to do on the right side. So we need to take the inverse matrix that we'll have to find and multiply it by these constants, 3, 4, and that is going to be our answer for xy. So right here is really the idea of how I solve it with inverse matrices. I find the inverse matrix, multiply it by the constants, and I have my answer. So we get to practice finding the inverse matrix again of that thing. So the inverse matrix will be 1 divided by the determinant. So 2 times negative 7 is negative 14 minus negative 15. I'll come back and simplify that. Times, and let's see if we can remember about those two diagonals. What do I do with the 2 and the negative 7? Switch them, change them. Negative 7, 2. What do I do with the 3 and negative 5? Change signs. Negative 3, 5. There you go. So let's see, what did we get in here? We have a negative 14 plus 15, so it's just 1 in front, isn't it? So if I multiply it by 1, then my inverse is -7, 5, -3, 2. So we are going to take that inverse and multiply it by the constants, those answers, -3 and 4, and when we're done, we should have our answer, our x and y values. Now, as a reminder, we learned how to multiply matrices, and they have to have certain orders. This first one is a 2 by 2. What is the order of the second? It's a 2 by 1, 2 rows, 1 column. It's always rows by columns. And you remember, if I am multiplying, these middle numbers must match, which they do, and the order of the answer will be the outside numbers. It will be a 2 by 1 answer. So we'll get a little practice multiplying matrices here. So we multiply rows times columns. So I go -7 times -3, the first number in the row times the first number in the column, 21. And then I move over and down, second in the row, second in the column. 5 times 4 is a positive 20. And that is my first row, first column answer. And since it's the only column, then I can just move to my second row, sticking with that column. -3 times -3 is a 9, and 2 times 4 is a positive 8. So we get 41 and 17, which I could say x is 41, y is 17. And we solved it with an inverse matrix. So this combines knowing how to find an inverse and knowing how to multiply matrices by hand. Yes.
So if we just leave it in the matrices, like the 41 and the 17, it's not correct, do you want to write it in that?
You will need to either put it in an ordered pair like this to tell me it is x and y, or do this for me. X is 41 and y is 17. Because I know that it stands for that, but I need to know that you know that it stands for that. What number did we just do? 76. 82. Okay. 82 says find the given minor and then the given cofactor for this matrix. So at this point, the only thing we have done on software is that inverse of a 3 by 3. Everything else, we need to be able to know by hand how to do the stuff so far. Let's copy that matrix, 2, -3, 4. So in 82, they're wanting minor sub 11 and cofactor sub 11.
That's 81.
Oh, is that the wrong one?
23.
23. 23 and 23. Minor sub 23. Let's work on that first. Minor stands for minor determinant. So when they say minor sub 23, it is row 2, column 3. So row 2, column 3, this is the number in row 2, column 3. So the minor determinant, we cross off the row and the column that number is in, and we'll find the determinant of what is left, that 2, -3, -2, 2. So this is called the minor. It's short for minor determinant. Okay, 2 times 2 is 4, minus -2 times -3 is 6. The answer is -2. So the minor sub 23 is -2. Now, cofactor sub 23. Cofactor sub 23 is where I need to use the number 3, position row 2, column 3, times -1 raised to the add 2 and 3 together, which is 5, times the minor that goes with 23. Well, we figured out the minor was -2, so I don't need to figure it out again. So I just do this math. Now, -1 to the 5th is -1. So 3 times -1 makes it a -3. -3 times -2, 6. Now, there is a reason why we did this. And yeah, maybe I have one of those. Let's see what I have next. What was that, 82? 682. I want to look at 86. I don't want to skip over that one. I want to look at 86 next. It says evaluate the determinant by expanding by cofactors. That's the reason we have this. Copy that matrix down. Earlier we found the determinant of a 2 by 2. It's simple. You multiply down minus, multiply that diagonal coming up. So our 3 by 3, we're going to use this cofactors method. We need to pick a row or a column to do. Any suggestions? Row 2?
Row 2.
Well, we have to have a whole row or a whole column.
Column 2.
Let's go with column 2. There's a whole bunch of zeros in there. We'll still set it up, but when we multiply by 0, it'll be easy to do that in our heads. So here's how it works. I need to start with that first number, and I need to find the cofactor that goes with that number. So I write the number down, then I write -1 raised to the, now what position is this?
1, 2.
It's 1, 2. So let me just say cofactor 1, 2. So I raise it to the third times the minor. So I need to find the determinant of, and I'm going to cross off the row and the column. Boy, that's a nice and straight line. The row and the column, try that again. But that is on. You want to stand up here this close and see. All right. So what I am left with is 1, -7, -2, 6. Now I'm going to keep writing, then we'll come back and simplify this. Plus, then we move down to the next number, which would be 0, -1, no, that's row 2, column 2, it'd be raised to the 4th, it always goes up in power, times its minor. Now I want us to practice writing it down, even though when we multiply by 0, we know it's going to be 0. So we're wanting to make sure we're good at this for tests. So 4, 8, -2, 6. That would be the minor that goes with that one. And then we would move down, plus 0, -1 would be to the 5th, and its minor, 4, 8, 1, -7.
So it's always times a -1.
Always times a -1 raised to the power of the subscript, the sum of the subscript. We have to add those numbers together. Now both of these are just going to be 0, that's why we picked it. Plus 0, plus 0. So we're really only going to have to do the math back here on this part. -1 cubed is -1. Times that 5 is a -5. So we know it's going to be -5 times, now we need to do the determinant. So 1 times 6 is 6, minus 14. So we get negative times a negative, -5 times a negative 8, which equals 40. There's the answer to the determinant of that matrix. It's 40. Now, if the other two didn't have zeros with them, we would have had to done all the math there and then added it all together. But that's why we picked the one with zeros. There you go. 92. 92. Boy, we haven't done much by calculators yet. proper software yet. 92, copy down the matrix. 3010. So the directions here, they say evaluate each determinant by using elementary row or column operations. This is where we learned if we can make zeros in this position, this position, this position, then all we have to do is multiply the diagonal together, and that equals the determinant. But if we interchange rows, it changes the sign of the answer, so we have to remember that. We're not going to interchange any rows, probably. If we just multiply one row by a number, it changes the determinant by multiplying by that number. We might use that, so let's see what happens. Oh, I'm going to use that one because I want to make this top one a 1 because then I can eliminate both of these things under it. So I'm going to multiply 1/3 times row 1. And that means we're going to have to multiply our answer by 3 to get it back to the real determinant. Because multiplying by 1/3, we just multiplied the determinant by 1/3. So my next one would be a 1, 0, 10/3. Doesn't look like 10/3. And copy the other two. I'm going to use that 1 and eliminate the stuff under it, and that has no effect on the determinant doing these row operations. -3 times row 1, add it to row 2. -2 times row 1, and add it to row 3. It's -5/3, is that right? You gave me a thumbs up, so I'm okay there? All right. So I've got my zeros just like I wanted them. I want to eliminate this -1 right here. So I am going to multiply this middle thing by a 1/2. -1/2. -1/2 times row 2. Now that means I'm going to have to multiply my diagonal answer by a -2. This is going to affect my answer. That's going to affect my answer. 1, 0, 10/3. 0, -2, -3. Whoops, forgot to multiply by -1/2, didn't I? 0, 1, 3/2. And then 0, -1, -5/3. I'm going to add row 2 to row 3, and that will give me my 0 right here, which is what I want. So adding them together. 0, 0. Okay, let's see. Common denominator is 6, 9, 6, 10. -1/6. Do that math for me. See if I did it right. 3/2 minus 5/3.
Yeah, -1/6.
All right. So now we're ready. All I need to do is multiply all this stuff together, which would be -1/6. And then I need to fix the two things where I affected it. When I multiplied by a -1/2, then I need to multiply by a -2 to undo that. And up here where I multiplied by 1/3, I need to multiply by a 3 to undo that. Well, this is interesting. What's the answer to that? 1. The determinant of this is 1. All right, let's see, 102, 105. All right, let's look at 105. They're both the same kind of problems. This is going to be a calculator problem. Kramer's rule, if it's a 2x2 system, I expect you to be able to do it by hand. That was the one, wasn't that our last section, Kramer's rule, the one we just did? Yeah. 2x2, I expect you to do it by hand. Anything bigger, we're going to use a calculator. So on 105, it says solve for x sub 3. So they only want one specific value. So we know the numerator is going to be the determinant where I have replaced what with what? Correct. We have replaced all the x3 coefficients, the column 3 coefficients, with the answers.
These are equations?
Yes. 1, 2, negative 1, 3. 1, 2, negative 1, 3. What's the second column?
Negative 3, 7, 4, 1.
And then our answers go in column 3, so what's that?
3, 2, negative 1, 3.
And then we're back to the normal x sub 4 column. All right. Divided by, what do we do in the denominator?
Divided by
The actual coefficient matrix.
3.
2, negative 1, 3. 4, 1. What should be in column 3?
1, negative 3, 2, negative 1.
All right. And then it's just enter it correctly. So we will see if I can enter it correctly. If I can send that in the corner where I can still see it. How big is this? This is a 4x4, isn't it? And watch my numbers if you would. So what do I need to find of this thing? I just entered the numerator.
To the right of the negative 2 should be a negative 4.
To the right.
No.
Okay.
Is that the second one?
This is the top one.
Well,
This
the
is the
second
top.
one should be the original one. Oh, yeah.
No, this is the numerator.
Okay.
Okay. Find the determinant. So I find the determinant, and it says negative 230. See if that will just allow me to copy that number. So I know negative 230. Look at that. That's my numerator. Right there. Divided by and all I need to do up here is fix my third column, isn't it? 1, negative 3, 2, 1. And find the determinant again. Oh, right here, isn't it? Right there? Negative 1. Is all the rest correct?
Yep.
Find the determinant. Negative 252. Well, that's a nice number. See if that reduces. 115 over what? Well, yeah, divide by 2, that works, huh? That's probably it, isn't it? Guess I could look. Yep. There it is. So if they ask you to solve the system, what do? Do it for all of them. The x of 1, the x of 2, the x of 3, the x of 4, whatever it is. That would solve the whole system. That's how Kramer's rule works. And 102 and 105 are both about Kramer's rule there. 108, transformations. So here's how it will work. If I give you a transformation problem, I do not expect you to memorize all the transformation matrices. I will supply you with some transformation matrices. You will need to know how to pick the right one and use it. So let's try 108. Triangle has vertices at these points. So we take the points, -3, 4, and these become columns with a 1 in the last position. 1, -1, 1, and what's point C?
0.
0, 5? 1. So we take the first two rows and they become the x and y for our points. So a triangle has vertices at these points. It says use transformation matrices to find the vertices of the triangle after it has been rotated 90 degrees about point 2, 3. 90 degrees about the point 2, 3. So, yes.
1, 1, 1, always go at the bottom.
Yes, ones always go at the bottom. The first two rows are the x and y, and then just a 1 at the bottom.
You would have to remember like all the equations, like
All the matrices?
8 terms, like 2, 7, 3.
No, you do not have to memorize the transformation matrices. I'll supply you. You need to be able to pick the right one and use it correctly. Okay? Yes. So how will they be labeled? That's a good question. Let's go back, find the page. I don't know what page it is. First person to find is just say the page number where those transformation matrices were. I found them. They're back on page 556, it looks like, is where they start. So they will be labeled just like they are labeled here. On 556, the first one says T, A, comma, B. It has been translated horizontally A, vertically B. You need to understand that. So that's how I will give them to you. Or I might say R sub X. That's a reflection over the x-axis. So you need to know what it means, but you don't need to know the matrices.
Can we graph these? So we're going to graph it on the test?
No, don't have to graph these. We're just finding the new coordinates, so we don't have to graph it. But this is a 3-step process. The rotation matrix, first find this 90-degree rotation matrix in the book. It's on page 558. That rotation matrix rotates at about the origin, but we are not on the origin. So step number 1 is to translate, and actually you need to know this one. You need to know the translation matrix. You need to translate it left 2 and down 3. Now let me do a little sketch. We're moving it to the origin is what we are doing. Right 2, up 1, 2, 3, right 2, up 3. This is the point. You need to move it to the origin. So we have to move it left 2, and down 3 so that we move it to the origin. So step number 1 is to do this thing. So that means, and the translation matrix, where was it? It's back on page 556. The translation matrix is real easy to remember. In these two positions, you just put what you're trying to do. Horizontally, left 2. Vertically, down 3. That's the x, that's the y. X is the horizontal, y is the vertical. And you have to multiply it on the left side of the matrix that you're working with. -3, 1, 0, 4, -1, 5, 1, 1, 1. So you need to remember that as well. So step number 1, we have to move it to the origin, which means I need to do this multiplication. And I'll do the multiplication over here. I'm not going to burden you with looking at it. Hopefully it will. Well, maybe I'll stick it over here so you can watch it, because that will make exciting video. I might be able to go to Southwestern and win a prize with this video. Just saying. All right. 0, -2, 0, 1, -3. All right, so I need to multiply these two together. So what does it say? Multiply them together. So there comes my multiplication. So we'll grab that. So I've accomplished number 1. I have moved it over here to the origin. Now step number 2 is I rotate it. So step number 2, we need to do the rotation of 90 degrees. And we'll have to do it on the left side again. You want to tell me what that one is? I don't have that one. There we go. Okay. So now we need to do that one. So that hopefully will not be too hard for me to take this answer, and I'm going to send it up to B. So I sent that answer up to B. Did it go? Yeah. And then on the left side, I need to do my rotation matrix. So this is all using software, so it does all the heavy lifting for you, but you still need to know what you're doing. All right, so now we will multiply it together. So multiply A times B. We get our answer. Now what do I need to do? I need to translate it back to where it came from. So step number 3.
Multiply by the thing on the left over positive 2 and 3?
Correct. We need to translate it now right 2 and up 3 to get it back to where it belongs. And that one, again, you should know, I should know, 1, 0, 0, 0, 0. So it's going to be right 2 and up 3. Do that down in the corner where we can see that one. So let's see, that -1. So I need to send that to matrix B, -1, 4, -2. There you go. And I need to do my rotation. What is it, a 2 and a 3? And we'll multiply those together. And that produces our answer, which we need to interpret as vertices in a triangle. So our answer is A prime, the new A, is 1, -2. And B prime, the new B, is 6, 2. And C prime, the new C, is 0, 1. So there's the answer to where are the vertices of that triangle after it has been rotated 90 degrees about the point 2, 3. What was that? 108. 110, a market analysis has determined that 20% of the people currently using the Quick Photo Computer program will switch to the Photo Pro program in the next year. Of the people using Photo Pro, 45% plan on switching to Quick Photo the next year. If there are currently 2 million people using QuickPhoto and 1.5 million people using PhotoPro, then assuming these trends continue, this matrix equation gives a number of people, Q, using QuickPhoto, and the number of people, P, using PhotoPro in years. Use this equation to estimate to the nearest tenth of a million the number of people who will be using each program in 3 years. So while I'm writing this down, you are going to be telling me how I get that answer, which should take you less than the amount of time it takes me to write this down. What do we do? We're going to use technology, but we have to know what to do.
Is Q on the left? Do you know Q?
When we get our answer from doing our work, Q is going to be on the left and P is going to be... Did I copy it right? Yeah. Substitute 3 for n. They gave you the equation. This is the equation that will give you how many people after n years, 3 years they told us, are using each program. All we do is exactly this, right here. So this means finding our software again. Where did it go? So I've got a smaller one. We'll clean that one up. I have a 2 and a 1.5. We'll clean this one up. 0.8, 0.2, 0.45, 0.55. And if you're really fancy, let's see if I can make it work. We're going to go matrix A times matrix B raised to the third. So that's what they've asked us to do here. Matrix A times matrix B raised to the third. Now you can do it manually instead of writing the little equation there, but writing the little equation there is nice and easy. Oh, let's display as decimals. That would be a much better thing to do. Let's do it again. So now we need to answer the question. And the question was what? Which program? QuickPhoto? I don't know. Is that what it is? Number of people using the QuickPhoto? There you go. Did they ask for both? Oh. QuickPhoto is 2.4 million people, and PhotoPro is 1.1 million people. There's our answer. Matrices are beautiful. When you have technology and know how to apply them, then you can answer some of these more complicated things. Number 112. Not going to run through the whole thing, but we'll remind you of how to do one of these. This also would be a technology one. We're not going to do this stuff by hand. We're going to let the calculator do the calculating, but we have to do the understanding and how to set it up. Each edge of a metal plate is kept at a constant temperature as shown below. Find the temperatures at each of the points, x sub 1, x sub 2, x sub 3, x sub 4. So we learned that any point is the average of its horizontal and vertical partners, the closest ones to it. So x sub 1 should equal, well, there's a 40 degrees and a 6, oh, wrong one. Oh, no, I'm not. 40 degrees and 60 degrees. 40 plus 60, x2 and x3, plus x sub 2 plus x sub 3. And we would divide that by 4, and that would be the value of the temperature at x sub 1. Now let me do some working with this problem. I'm going to multiply it by 4 to get rid of the fraction. 4x sub 1 equals, add the 40 and 60 together to get 100. Then I'm going to rearrange it as a linear equation. Now we go all the way up to x sub 4, don't we, on this one? So there's really 4 places. So if I wrote this, this is 4x sub 1 minus x sub 2 minus x sub 3. I'm going to leave a little space, equals the 100. So I've just rearranged it into a linear equation in order. We'll do one more of these, and then I'll talk about how we would finish it up. X sub 2. It's 60 and 70, x4 and x1. So 60 and 70 plus x1 plus x4, and if we divided it by 4, that would be the average. So if I multiply it by 4, 4x sub 2, add the 60 and 70 is 130, plus x sub 1 plus x sub 4. And I'm going to rearrange it into this order. So I'd subtract the x sub 1 minus x sub 1. I don't have an x sub 2. Oh, there I do. Plus 4x sub 2. Plus 4x sub 2. I don't have an x sub 3. Minus x sub 4. And it equals 130. Now we would continue until we had all 4 equations. And then what would we do? We want to solve this, and so since I'm going to allow you to use technology, I would use the inverse matrix way of solving it. So let me back up a minute. Let's find that inverse matrix way of solving it right here. We know our answers are x sub 1, x sub 2, x sub 3, x sub 4 will just be the inverse times those answers, those constants. So what we would do is we would put this into a matrix so that we could find the inverse of it. The 4, -1, -1, 0, and the -1, 4, 0, -1. So I'm doing a coefficient matrix is what I'm doing, etc. We'd have 2 more rows. Now, let's see. We know times the x sub 1, x sub 2, x sub 3, x sub 4 will equal the 100, 130, etc. We would have 2 more numbers. So all we would need to do then is take the inverse of this matrix, multiply it by those answers, the 100, the 130, etc. And there's your answer. Whatever you get from this is what x sub 1, x sub 2, x sub 3, and x sub 4 is. So we're using our knowledge of, hey, I can solve a system using inverse matrices. But we'll let the calculator find the inverse matrix and do all the multiplying together. Where back here, we by hand on a 2x2 system found the inverse matrix and multiplied them together, and that was our answer. Same kind of problem. It's just we use the technology, but we need to have the knowledge to set it up and make it work. I want to back up to 59. So I noticed another topic there that didn't show up on this. Oh, well, it's on the list, isn't it? I just skipped over it as we went along. So let's back up and look at 59. Now this one also would be a technology one if you got a question from here. It says find the adjacency matrix A and then A squared for the graph at the right, and use A squared to determine the number of walks of length 2 from vertex 1 to vertex 5. So we'll have to remind ourselves about these adjacency matrices. What do we have, 4 points or 5 points? 5 points. 1, 2, 3, 4, 5. The adjacency matrix was how many steps to go from, first of all, 1 to 1? 0. There's no steps to go from 1 to itself. From 1 to 2, how many steps? We've just one. From 1 to 3. Just a minute. Let me remind myself about the adjacency matrix to make sure I'm answering it right. We all had a spring break, didn't we? Where did we have these adjacency matrices?
Doesn't have to be like the direct path.
559.
Something about direct path. 559. Here we go. Yes, the number of direct paths. That's what it is. The number of direct paths. So if we go back from 1 to 3, how many direct paths are there from 1 to 3? 0. That's a 0. From 1 to 4? 1, and from 1 to 5? 0. There we go. And then when I start the second row, it's between 1 and 2, which is 1. 2 and 2 would be 0. 3 and 2, or 2 and 3, what is it? 1, 2 and 4? 1, 2 and 5? 1. All right. 3 and 1? 0. 3 and 2? 3 and 3? 3 and 4? 3 and 5? 3 to 5? Direct paths. All right, now we're 4 to 1. 4 to 2. 4 to 3. 4 to 4. 4 to 5. 5 to 1. 5 to 2. 5 to 3. 0. 5 to 4. 0. 5 to 5. 0. There's the adjacency matrix. So they said, now square that, because they want to know the number of walks of length 2. If they wanted the number of walks of length 7, you would... That was not a rhetorical question. You would raise it to the power of 7. Yeah, that's all you would do. What am I, 4, 5? Oh my. 0, 1, 0, 1, 0, 1, 0, 0, 0, 0, 1. Is that right? Sure, better be. Square it. Square it. What do we want to do? Multiply by, raise it to the power of 2. Square it. Now we have to interpret this. Where did it go? Here it is. What was our question? Vertex 1 to vertex 5. So how many walks of length 2 between this? Between 1, row 1, column 5. 1 and 5. Or if you want to, you can do row 5, column 1. Same answer. 1. There's our answer to that one. All right, we're done reviewing together. Test is next class period.